Bismillahirrahmanirrahim. Today's topic is chapter number 1, functions and limits. By the end of this lesson, you'll be able to find what is a function, domain and range of a function, and how can we find domain and range of a function. Then 4 important ways to represent a function. Then systematic way of finding domain and range of certain functions. First topic is function. Whether you realize it or not, you use the concept of function frequently in your everyday life. Being engineering students, you already know that the acceleration of an airplane on takeoff is a function of the thrust of its engines. The depth of field in a photograph is a function of the lens's opening. So in each of these situations, we are saying that the first thing is dependent on the second independent. In mathematics, the word function is used in much the same way, but more restrictively. Thus, the mathematical function demands that one quantity is uniquely determined by one or more quantities. Now, let's see the mathematical definition for a function. A function is a rule or correspondence relating two sets in such a way that each element in first set corresponds to one and only one element in second set. Now, what is domain and range of a function? Let y equals to f of x be a function of independent variable x. The set of real numbers that can be substituted for the independent variable x and give real numbers for the dependent variable y is called the domain of the function. Now here, f of x is your function, y is your range, and x is your domain. The values of y are depending upon the values of x. So we can say that x is an independent variable and y is the dependent variable. There is another name of domain and range as well. You can say that domain is the input of a function and range is the output of your function. So here is the definition of range. The set of real numbers obtained for the dependent variable y is called the range of a function. In this function, y is your range and x is your domain. Then independent and dependent variables. As I have just talked about dependent and independent variables, in this function, x is your independent variables. The values of x are not varying on the values of y, but the values of y are depending upon the values of x. Your output always depends upon your input. That is why we can say that y is the dependent variable and x is the independent variable. So let's see the definition. The definition is here. The variable x is called the independent variable of function f, and the variable y is called dependent variable of function f. Now, for representation of a function, we can represent a function symbolically, numerically, graphically, and verbally. Let's discuss how can we represent a function symbolically. A function f is said to be represented symbolically or algebraically if for each x in the domain f of x is equal to some algebraic expression involving x. Since almost all algebraic operations give unique result, there is usually no problem in determining whether an algebraic expression involving x defines a function. For example, since squaring a number gives a unique answer, the expression f of x equals to x squared is a function. Another example for it is, since adding two numbers gives a unique answer, the expression g of x equals to x plus 5 is a function. These are the examples of function, and see, we are representing them algebraically. This is an algebraic expression and we are representing our function algebraically. As I've told you before that y equals to f of x is a function. It represents a function, and f of x, if you are using algebraic expression instead of f of x, then the function is you can say that it is an algebraic function. Let's take another example. What about the expression under root x? Any idea? What about the expression h of x equals to under root x? Although the square root of a positive number is not unique, when we use the symbol under root x, we mean the positive square root of x. So we can say that h is also a function. Except possibly for doing the algebra, it is usually easy to find the domain of a function which is represented symbolically. In general, there are two reasons why a number is not in the domain of a function. So let's consider how can we find a domain of a function. How can we relate domain of any function? The first thing is it should not be divisible by 0. Division by 0 means in the denominator part there should not be 0. If it is 0, it is undetermined. Your domain is not defined then. Second is square root of a negative number. You can't take square root of negative number. If a number which gives you negative answer under the radical, it means that that value for the variable is not part of your solution. It won't be taken as your domain. Second, it is, as an example of 1, consider f of x equals to x by 1 minus x squared. Now let's find its domain. The domain of f consists of all real numbers except minus 1 and 1. So see, if I'm putting the value of x 1 here or minus 1, the denominator part becomes 0. So we can't take these two values of x as our domain, since it does not satisfy the condition. Now let's take another example. The example for this second definition we get, which is square root of a negative number. How can we say that we can't take square root of a negative number? I'm considering this example. G of w equals to under root 4 minus 3w. For w to be in the domain of G, we must have this condition: 4 minus 3w should be greater than or equal to 0. Now we will be applying this condition. Solving this inequality for w, we get 4 by 3 should be greater than or equal to w. So the domain of G is the collection of all real numbers, that is less than or equal to 4 by 3. If you are putting the values of w less than or equal to 4 by 3, it will be satisfying your function. So what is your domain? So your domain will be all real numbers less than or equal to 4 by 3. What if you are putting w as 4 by 3? Yes, it will be satisfying the condition. You won't be getting negative sign under the radical. So you can take it as your input, or you can say that it can be your domain. Now let's see the examples combinedly, both the parts combinedly. Here I'm considering this function h of s equals to 1 divided by under root 3 minus s. Now let's solve the function mathematically. If you are solving this inequality, 3 minus s greater than or equal to 0, so we make sure that we do not take the square root of a negative number. Next, we exclude s equals to 3 so that we do not divide by 0. Hence, the domain of h is all real numbers less than 3. So, if you are inserting some other value which is less than 3, you will be getting correct answer. But if you are inserting something greater than 3, see, your radical part will contain negative number. It will be negative number under the root. So you can't define your domain for that. So what will be the domain of this function? You can't take the value as 3. because if you are taking s as 3, your answer will be 0. So 1 divided by 0, your function is not satisfying it. So you can't take your domain as 3, and you can't even take your domain as less than 3, greater than 3, because you'll be getting negative sign under the root. When we are looking at the application of calculus, the domain can be further restricted by the application. We can say, for example, if a of s equals to s square. Now here we are applying them practically. When we are interested in finding area of a square, so s represents one side, s square represents area of a square. So what will be its domain? Then the domain of A is the collection of positive real numbers, since the side of a square must be positive. So here, finding the range. Now how can you find the range of a function? Let us find the range of f of t equals to 3 minus ft. We need to find the collection of all ft's. Hence, we ask the question for what number z can be equals to f of t. To answer this question, we set z equals to 3 minus ft. Now here there are few steps. I'll be explaining you in my next example, which I have solved it for you, how to take few steps and how to find range of any function. Because domain, you can easily define domain of any function, but for range you have to solve it. You have to mathematically take few steps mathematically, so that you can easily relate your range. So your first step is z equals to 3 minus 5z. Now here you have to extract this variable t. You have to evaluate the value of t by shifting the terms here and there. So if you are shifting 3 on the other hand side, it will become z minus 3, and when minus 5 is being multiplied with t, on the other hand side, it will be in the division. So the value of t is z minus 3 minus 5. This tells us that the function f of t, now what was the function? F of t equals to 3 minus fz. Here f of t equals to z. F of t equals to z, because we have related f of t equals to z. This is the value of t, which we have extracted it from the equation, which is equal to z. Now, if we are choosing any number, hence the range of f is the collection of all real numbers. Let's take 10. Why is 10 in the range of f? This is just for verification, so that you can understand it clearly, that why any real number can be a part of its range. Now, if you are inserting the value 10 here, what will be your result? What will be your result? If instead of z you are inserting 10, 10 minus 3 gives you 7. 7 divided by minus 5 is minus 7 by 5. If you are inserting minus 7 by 5 here, your answer will be equal to 10. Why? Because we have taken z as 10. See, if you are inserting instead of z 10, 10 minus 3 divided by minus 5, which is equal to 10. So if you are inserting minus 7 by 5 in this equation, it will be satisfying it. As another example, let us find the range of this function. Again, name the function z equals to 2y, y plus 3. I told you that you have to extract this variable. Let us extract it. Let us separate it. Solve this function for y. When you are separating, when you are taking few mathematical steps, see, you have extracted this y from this function. Now, when once your value is extracted,